So this question asks you to describe the transformations of the function of this that occurred from this function here. So this was your old function, and this is the new function, or the image. So essentially what we're doing is we're listing the transformations, so we're providing information about the dilation, the reflection, and the translation of actually converting this old function into the new one. So we're going to start up with just making the comparison. So we're going to write y equals to x cubed on that side, and then on this side of the equation, I'm going to put dashes here indicating new equation. Okay, so this was our old, and this is the image. And so we want to know exactly how we converted our old equation into our image equation. And so what we're going to do is, the first thing, we'll move the all the values that belong to y over to the side of y. So what we're going to do is we have y dash minus 1 equals to minus, and then we move that negative over to the other side. Whereas here, we still have y equals to x cubed. Okay, so once we've done that, we are going to be comparing our y values together and our x values together. So, minus y dash, so I'm just extracting the y information, and then I'm going to make the x information equal to one another. So this x is just x to the power 3, and whereas this one is a little bit more complicated. So I'm just going to write x equals to 4x dash minus 3. And once you have these equations, that relate your y values to your old y value to the image of the y, and your old x value to the image of x, you should have a go at rearranging it. And to rearrange it, hang on, I've lost it. Okay, so we want to rearrange the equations and obtain information about how we've manipulated the old y value to get the new one. So it's important to actually define the image in terms of the old y values. So let's move that 1 over to the other side. So, and let's keep this y dash. And then I'm going to move or transpose the negative to the other side, but then I'll also rearrange this whole formula. So if I move the negative over to the other side, essentially what I'm doing is I'm multiplying this side by minus 1, and I'm multiplying that side by minus 1. And what that means is that each one of these terms need to be multiplied by minus 1. So I've got minus y plus 1. So that's what has happened. And I do the same thing here. So x plus 3 all divided by 4 equals to x dash. Okay, and then I can make x dash equal to, take out the quarter and just write x plus 3. Okay, so now that we've done that, we can then discuss the dilation. So in this case, there's a dilation, and there's no y dilation because there's no number in front of y that's greater than 1, okay? But there is an x dilation. So dilation by a factor of a quarter, and what's happening to the x values, if you consider 1 and 1, and suddenly you're timesing the x value here. Here is your x value. If you're timesing it by a quarter, suddenly it's here. So it's a quarter and 1. So it's actually being translated, it's being dilated parallel to the x-axis or towards the y-axis. So parallel. Okay, so then that we have our dilations, we now concentrate on our reflections. So to understand what our reflections are doing, we've got a minus in front of our y. So if you imagine if you had the point 1 and 1 here, and you put a negative in front of that y value, it's now down here. This is a reflection in the, you can see it's a reflection around the x-axis. Here is our x-axis, and that's a reflection. So it's a reflection about the x-axis. Now I've lost my marker. Oh, there it is. Reflection around okay, and finally we have our last part, which is the translation. So we have a translation of 1 unit up in the positive y direction, 1 unit in the positive y direction, and we also have a dilation. So if we have, again, the point 1 and 1, the first change that has occurred is that the whole, this point here has been, no, not that point. We're now looking at the x. So this point here has been moved up by 3, well, to the right. So it's been 4 over, it becomes 4 over, well, to get from that x value to that x value to the image x value, you have to add 3, which is exactly what it tells you in the bracket there. And then at the end, we're going to be timesing it by quarter. So it's still a translation by 3 units in positive x direction. Okay, so those are our transformations. So it is tricky to figure them out. I do suggest drawing a lot of images, a lot of axes, thinking about what the point is doing, and then just trying to break down the question as far as you can.